All right, ladies and gentlemen, you should have this particular page in the notes that I provided you. Please print off a copy of it. I think it's like page 15, so that you can follow along. All right, so you'll notice that there are no labels on these graphs, and generally speaking, if you have polynomials, fairly simple ones, then the more simpler it looks, the higher the derivative. So you'll notice that I labeled this first one as f prime and the other is f double prime. It's kind of an informal way of looking at it. If we were being strategic, we should be able to see that if this one is labeled f prime, where f prime is decreasing, your second derivative drops below the x-axis. Here too, where f prime is increasing, moving upward, your second derivative is above the x-axis. So I have labeled these appropriately. Okay, you do have another set of problems where one of them is a wave and I think the other is a parabola. The wave is the more complicated one, so it would be f prime, and then the parabola would be your second derivative. But in any case, let's get to it. Most of the rules are going to say positive, 0, and then negative. Okay, remind us to look above, at, and below the x-axis. So let's see if we can find those points of transition. You always want to start with f prime, always, right? So right there at x equals 3, something interesting is happening. Right here at x equals 9, notice that's where f prime crosses the x-axis. So let's have at it. Okay, I'm going to zoom in so that you can kind of see what I'm doing. All right, so from here to here, what can we say? We can say that f prime is above the x-axis. So we can say f prime is greater than 0 in here. Okay, so here we go, from here to here. What can we say about f prime? I'm going to put it right up here. We can say that f prime is below the x-axis. You can see it right there. Below the x-axis, that entire region. And then over here, we can say that f prime is above the x-axis again. All right, now I'm going to code switch. It's in my best interest to code switch. So what does this mean? If f prime is positive, this means f is increasing. This also means f is increasing. And then over here, where f prime is negative, this means f is decreasing. All right, so let me show you a general sketch of f of x. All right, usually I draw it directly on the page, but I don't have a ton of space, which is why you're not going to see me do that. Okay, so just based off of this, noting that this is x equals 3 and x equals 9. So here's x equals 3. And right here, I have x equals 9. Just based off of this information right here, nothing else. I can say f increases, and here, this is f of x. Okay, I didn't have it, but now I do. F decreases in here. Oops, I don't want to pass that, right? Because those are critical points. And then f is increasing over here, right? So this is a general sketch of f of x with nothing else. All right, so let me go back. And I got to be really careful. Let me show you something. Before I get too excited, what do I mean by positive? I mean f prime is above the x-axis from there to there. And f prime is above the x-axis from there to there. And over here, you'll notice f prime is below the x-axis in this region, like that. Okay, now I'm going to turn my attention to f double prime. F double prime. Okay, so I'm going to do the exact same thing. However, I have to now look at where the second derivative, give me a second, has something on it. The second derivative drops, it hits the x-axis, which is right here at x equals 6. Right? So what happens? Okay, again, I'm sorry that I don't have enough space. This is just what was provided in your homework. From there to there, and then from there to there. Right? So look closely. Your second derivative is in the negative region in here. F double prime negative. And then over here, if you look closely, your second derivative is above the x-axis. F double prime positive. All right? So let's think about what the rules say about F. If the second derivative is negative, this means F is concave down in here. And if your second derivative is positive, this means F is concave up. All right, let me show that to you. Okay, because the second derivative is negative, your function should be concave down. And over here, look, second derivative is positive, so your function should be concave up. So what does that look like on our graph? On this, right? We're trying to sketch out f of x. Okay, so we already know right here at x equals 6. That's that squiggly line right there. And I'm going to use what we learned right here. Your function should be concave down until the squiggly line. Okay, I still have to obey the arrows. Please keep in mind that I want to obey the arrows. All right, so I should still have a max at x equals 3. That doesn't change. Okay, so here I want to obey the arrows. I want to pick this up and be concave up like that. Now guess what, folks? You should be able to answer all of these questions because those questions flow from one of these two graphs, either f prime or f of x. All right? So let's just run through a couple of them. This is where is f prime equals 0. Right? So sometimes it's in your best interest just to look right at the graph and determine what the answer would be. So f prime, this is f prime right here. So they're saying, where does f prime meet the x-axis? There you go. X equals 3 and x equals 9, right? That's what equals 0 means. So this one would be x equals 3 and x equals 9. Number 3 says, when is f double prime equals 0? Well, this straight line right here is the f double prime. You end up crossing the x-axis at x equals 6. Number 4 says, where's f prime in the positive region? Where's the parabola above the x-axis? Okay, so there's two spots from negative infinity to 3, and then from 9 to infinity. Number 5, where's the first derivative, this one, below the x-axis in the negative region? So that's from 3 to 9. Number 6 says, when is f increasing? Now I'm going to pull f out. Right there, I got the graph. I sketched it already. So you could see that f is increasing from negative infinity to 3 and from 9 to infinity. Both spots where f prime is above the x-axis. So negative infinity to 3 and 9 to infinity. Notice this is a repeat from 4. 4 and 6 are the same. Okay. For number 7, it says, where is f decreasing? Again, I already sketched f. This is f. So you could say from 3 to 9, f is decreasing. From 3 to 9. Number 8 says, where is f double prime in the positive region? This is f double prime. F double prime is in the positive region from 6 to infinity. Number 9 says, where is f double prime in the negative region? Right there. Negative infinity is 6. F double prime drops below the x-axis. Negative infinity is 6. Okay, you do have these written out, so if you can't see it from me moving the page, then please look at what has already been written out for you. Number 10 says, when do you have a point of inflection on f? Here is f. And you can see right there at x equals 6, you have a point of inflection. Number 11 says, where is f concave up? This is f, right? You can see it. F is concave up from 6 to infinity. which is the same answer as number 8, where the second derivative is positive. Number 12 says, where is f concave down? Here's f, I just sketched it out, from negative infinity to 6. And then 13 is an interesting one. It says, when is f prime increasing? This is like the first time that you want to look right at f prime and look at its behavior. F prime is the parabola, and they're saying, where is this parabola moving up? Look right there. You can see the parabola moving upward from 6 to infinity, which coincidentally is where f double prime is positive and your function is concave up. And then finally, where is f prime? This function here, where is that decreasing? We can say that that's from negative infinity to 6. Okay, which is where your original function is, sorry about that, I have something bumping up against it, where your original function is concave down and your second derivative is negative.